Good morning to all. Welcome to my channel FIELDS-07. Today we discuss electric charges and electric field. This belongs to 12th standard first lesson. In this one we discuss motion of charged particle in an electric field. See, for example, here we can write first problem. So before that, electric field, we know electric field means a region around a charged particle. For example, this is the positive charged particle. Around some region, a force is exerted on another charged particle. Means a region around a charged particle within which a force is exerted on another charged particle, that region we call it as electric field. So for that, for particular point, this point P, we find out electric field. What is the electric field now, or distance from this point? See, electric field equal to kq by r square. kq by r square. So for example, that type of electric field here. Here positive charges is there. See, positive charges. See, positive charges. See, this is the negative charge. Here positive and negative charges, these are parallel to each other. See this one. So positive charge, negative charge. Electric field is always from positive charge to negative charge. We discussed electric field originates from positive charge and terminated at negative charge. See, it originates from positive and terminated at negative. This is the direction of electric field. See, this is the direction of electric field. See, electric field direction, this one. See, in this one, for example, see, this is the electric field. Uniform electric field means electric field lines are parallel, straight and equispaced, represent uniform electric field. In this uniform electric field, a charged particle is placed. Q, for example, a charged particle means Q here. It is placed. What happened now? A force is exerted on this charged particle. Force is exerted on this charged particle. It is positive charge now. Force is in the direction of electric field. That force is F equal to QE. This is the force exerted on the plus Q charge when it is placed in the uniform electric field. For example, here minus Q we can place. Force is exerted in this one, that is minus QE. So it means that minus means opposite direction. Just force is exerted on the charged particle, negative charged particle. When it is placed in the uniform electric field or electric field, it will be opposite to electric field. Positive charge na in the direction of electric field, negative charge na opposite to electric field. Force is exerted on this charged particle. So means a charged particle is placed in the uniform electric field if force is exerted. For positive charge in the direction of electric field, negative charge opposite to electric field. Now we discuss here, in this case, this is the electric field, means positive to negative is there. See, here charged particle is there, its velocity is v naught. So this is the charged particle, it has mass m and charge is q. So means here this one is in this electric field. See, moving with velocity v. So this will be moving like this actually because of positive charge. For example, here it is electron now, it is moving towards positive charge. Means plus charge now moving this direction. Here electron is there, means electron is placed in between these charges, means in electric field, moving in the electric field. That case it's deflected towards positive charge. So this case, what is the deflection in y direction, that we want to find out. This direction, what is the deflection in y? So that we find deflection in y direction, in y, yes na? And also find, and also theta means angle at which it emerges, angle at which it emerges. This only we find out, theta value and y value we find out. When the particle is, means charged particle is moving in the electric field, uniform electric field, a force is exerted on the charged particle. Because of that, some deflection is there and it moves with some angle. So that angle and deflection we find out. For that, see here, it is the initial velocity. It is the electron or charged particle, means E, electron. See, means electron is moving towards the positive charge. That's why it will deflect in this direction. See here, this is the deflection in y. This distance is here along x axis, we can take x distance, it is y, we can use y axis. See here in this case, we want to find out what is the deflection in y, what is the theta at which it is emerges. For that we can use means equations of motion. So that we can use here. See in this one we can write first x direction. Along x direction, what is the initial velocity, what is the final velocity, what is the acceleration, what is the displacement, all we can write it. In y direction also we can write. We use equations of motion for finding deflection in y and theta angle. See along x axis, here see initial velocity ux, what v naught. See along along x axis v naught is there, final velocity no, so 0, vy equal to 0. See t equal to acceleration, we can write acceleration along means x axis na 0, yes na. See time na t, time is t, and what na displacement is x equal to x, displacement along x axis is x. See this case we can write s equal to ut plus half at square. What is the acceleration along x axis na 0, initial velocity v naught, time is taken to here moving, time is t, displacement is x. Now we find out what is the displacement along x axis, xx, ux, here ax. We can substitute the values, we get the answer. See here, right, sx na xi, right, so ux na v naught, t value t, and half a value 0, ax is 0, so means t square, this total term is 0. So what we get, x equal to v naught t. So t equal to what, x by v naught. What is the time taken to, what is the time taken to reach from here to here? So what na, x by v naught. See in this one, this is the uniform electric field due to plus and minus charges, the electric field direction is downwards. In this case a charged particle means electron is moving in this uniform electric field, a force is acting on this one. See but here see negative charge, it will be means moving towards the positive charge, so that's why it will be deflected this direction. What is, how much deflection is there along y axis, that we can note, or at what angle it emerges, so that we find out. For that we can take what is the x direction, what is the y direction, we can take by using kinematics, equations of kinematics. So ux equal to initial velocity v naught, acceleration along x axis 0, time taken t equal to t, sx means along displacement x axis displacement is x. So we use equations of second equations of motion. What is that, sx equal to uxt plus half axt square. Sx na x displacement, ux na initial velocity along x axis v naught, time t, half ax is acceleration along x axis 0, so this value 0, so x equal to v naught into t equal to x by v naught. What is the time taken to cross the this na electric field na, that is x by v naught. What is the time taken to reach here, so that is x by v naught. See now y direction we can take. See here in y direction, so ux, sorry uy, along y axis initial velocity is along y axis 0, along x axis v naught, y axis 0, it is no. After that it will change its velocity. See here uy equal to 0, acceleration along x axis is, for example y axis is, force is here what, F equal to QE. So force means here MA, that equal to QE. So A equal to what along y axis, QE by M, QE by M. So means Q means here E, electron, so means EE by M. What is the acceleration of the electron charged particle along y axis na, AY equal to EE by M, along x axis 0. So here E by M, this is the acceleration of the charged particle when it is placed in the uniform electric field, uniform electric field. See this time na, time t, time t means here what is the time taken to from here to here, same here to here also, so that's why time equal to what here, x by v naught, x by v naught. See displacement from here to here, y displacement, y deflection, so y minus y equal to y. So we can use now equation, second equation of motion, sy equal to uy plus half ay t square. Uy na 0, initial velocity along y axis is 0, rest only. So Sy means y equal to half Ay means Ee by m. P capital E by m into t value is x by v naught. I write here x by v naught whole square. So means what we get, y equal to E x square by 2m v naught square. It is the deflection along y axis. See first what, now here uniform electric field is there, charged particle is moving in this uniform electric field, a force is acting on that one, that force is F equal to QE, from that acceleration equal to QE by m we can write it. In this case, see here, because of this charged electric field and this charged particle is negative, so your positive charge, it will be deflected towards positive charge. When an electron is here, so that will be deflected. Force is acting but acceleration is deflecting this direction. So it has some acceleration. That acceleration along y axis is E by m. So x direction we can write ux, ax, t equal to t, sx equal to, from that we can find out what is the time taken from here to here reaching. So that time is x by v naught. Along y axis, y direction, see uy equal to 0, ay e by m, t equal to x by v naught. What is the time taken from here to here? Same here to here also same time. That's why x by v naught. Sy equal to, what is the deflection here, y. So for that we can use second equation of motion. Sy equal to, s equal to ut plus half at square. Actually Sy equal to uy plus half ay t square. So uy means 0, half a value is what, E by m. I write here E by m into time is what, x by v, x by v naught whole square. So means x square by v naught square, x square by 2m v naught square. It is the deflection along y axis when the charged particle is placed in the uniform electric field. What is the angle? For example, see here we can take this point. It is along x axis Vx, final velocity, Vy along the y axis Vy. So what we can write, we find out along x axis, what now, Vx equal to u plus at. This is the formula for finding final velocity of the charged particle when it is in the uniform electric field. So that case Vx equal to u plus at, ux here, ax here. Along x axis na, Vx equal to what we can write, ux means v naught. I write here v naught plus ax means 0 into t, 0. So that's why along x axis, what is the velocity now, v naught, x direction. So y direction, so we can write y direction same. See what is the formula now, Vy equal to u plus at, u plus at, Vy, u means 0, initial velocity along y axis, ay, so this 0. So what we can write, Vy equal to ay means E by m, E capital E by m, t value means x by v naught, this one x by v naught, x by v naught means y axis, along y axis final velocity is x by m v naught. This is along y axis, this is the along x axis. So this is the velocities along x axis and y axis. We want here, what is the angle here, theta angle. Theta means here slope, slope na here, see this is Vy, so means tan theta, so means means opposite side by adjacent square, means Vy by Vx. So means tan theta equal, at what angle it emerges, at what angle, which angle it emerges. So that angle is here we can write slope. Slope means here theta. So means theta means here tan theta. So tan theta equal to what, Vy by Vx. Vy is what, Vy by Vx. What is the Vy value here? We are getting here Vy E by E x by m v naught, Vx value v naught. So we write here v naught by 1, that means we can change that na, tan theta equal to x by m v naught 1 by v naught, means here we can get, so tan theta equal to x by m v naught square. It is the, so angle at which it emerges, means theta equal to tan inverse of E capital E small x by m v naught square. It is the theta at which the charged particle is emerges. See again once, it is the electric field, uniform electric field, charged particle is moving in this uniform electric field, force is acting downwards, because of this negative charge it will be deflected towards positive charge. So what is the deflection in y direction, what is the angle at which it emerges, that only we find out. For that we can use equations of motion. So see here x direction, y direction. We can write what is the x direction, initial velocity, acceleration, time. We can take and find out what is the time taken to reach from here to here. That time is x by v naught. In y direction, uy 0, ay ee by m. Why not? What is the force acting on charged particle QE ma? So means along y axis only is there acceleration. See, that's why QE by m. So means along y axis ee by m acceleration. Along x axis 0, no acceleration. So that's why see, we can write it. See, by using these values we can use what is the displacement along y axis, deflection, as y s equal to ut plus half at square. Along y na we can write y. So y means what is the displacement y. So y equal to 1 by 2 a, this value 0, uy is 0. Why? Because initial velocity of charged particle is 0. So ay ee by m t x by v naught we can write. So y equal to e capital E x square by 2 m v naught square. This is the deflection of charged particle when it is in uniform electric field along y axis. Now we find out what is the theta at which it emerges. Here theta at what angle it will emerges out. So that we find out. For that, x direction, Vx equal to Ux plus At. So Vx, Ux na V naught. A acceleration along x axis 0. So this value 0. So Vx equal to V naught. Along y axis, Vy equal to Uy plus A Yt. So Uy 0, Vy equal to A value is acceleration along y axis is E capital E by M into t value is x by v naught. So means E x by m v naught. This is the acceleration along y axis. Velocity along y axis, final velocity. Now see here slope. Slope means tan theta equal to v by vx. Tan theta equal to E x by m v naught. This value we can write v naught means vx value. So what we get, tan theta equal to E x by m v naught into 1 by v naught. Why? Because it will be changes to numerator na, 1 by v naught we get. So means tan theta equal to E small e capital E x by m v naught square. Small e means charged particle, E means electric field, x means deflection along x axis, means displacement along x axis, m means mass of the charged particle, v naught means initial velocity of the charged particle. So now by using that we can find the what is the angle at which it emerges out from the electric field. So this is the answer. So deflection along y, theta at which it emerges. Okay na? Right. So next problem we can see here. So they will give different charged particles in the uniform electric field. For example, see here, this is the electric field. Here negative charge, electric field is positive to negative, like this is there. See here charged particle is there. So one will be moving deflecting like this. This is the first charged particle. Next one. So second one also deflecting here. Second particle. It is the middle in center. See it one another charged particle. See like this deflected. In this one, find which one have more deflection. What is that we find out. Find the, means which particle has, find deflection means find which means otherwise we can find which particle have highest deflection, highest deflection, that we find out. See here. So and what is the charge of that particles also? And the charge of particles, charge of particles. So plus particle plus charge or minus charge, that's one. See here first plus one, first charge particle plus one. So means first particle. What here it is moving towards positive charge means, so first particle is negative charge. Negative only attracted by the attract the positive charge. That's why second particle, second one also negative. Why? Because it negative charge only attract the positive charge. Third one is positive charge. It has see deflection. This one is deflection. This one is more deflection. Means third particle has highest deflection, highest deflection, highest deflection. And what is that now? Y equal to, this is the formula, E x square by 2 mv naught square. This is the deflection along y axis. due to this particle, due to a uniform electric field. So first particle is negative charge. Why we are saying negative now? It is moving towards positive charge. Automatically it is negative. Second also moving towards positive charge. That's why it is negative. Third one moving towards negative charge. So means it is positive. So means third particle is positive charge and deflection is highest. That deflection is y equal to E x square by 2m v naught square. 2m v naught square. Next, the third one. See here third problem. Here na find the minimum value of v naught. Find the minimum value for v naught. V naught such that, find the minimum value for V naught such that the charged particle just crosses the plates. Here see, it is the positive plate. Yes, na positive charge. Here negative charge. Here see, here particle is there. It is moving with V naught. What is the minimum value for V naught? For just crossing the plates. See, it is actually, this is the direction, but it is moving this direction. See, what is the, at what minimum velocity it just crosses the, at minimum velocity, for what minimum value of V naught it just crosses the plates, that we want to find out. See in this one, this is the direction of electric field. Yes na, see this is the direction of electric field. So means positive to negative. So V naught is the initial velocity of the particle and it is the deflection in y direction. This is the deflection in y direction. See this case, this length is L, length of the plates is L. It is the initial velocity of the charged particle. Now we can write here, like before problem, we use equations of motion. So along x axis we can write, along y axis we can write. See along x axis, velocity, initial velocity equal to v naught, acceleration along x axis is 0, time taken is t. So displacement along x axis is L, we can write this. Along x axis L, why not this is? See, we can write here y direction. See, along y direction V uy equal to 0. Acceleration along y axis now here, force is what? Force equal to QE. Yeah, so means force means MA equal to QE. A equal to along y axis QE by M. So this is the acceleration along y axis. So we can write here Q E by M along y axis. See along y axis displacement is y. See we can write Sy equal to Uy plus Uy into T plus half A T square, Ay T square. See Uy means here, y now here we can write here, this distance between the plates is D, this distance is D by 2, they gave in problem only. See, this is the electric field, uniform electric field. A charged particle is moving in this electric field. So while crossing, at what minimum velocity this charged particle just crosses the plate, that only we find out. For that we can write what is the x direction, initial velocity, acceleration, all we can write, y direction we can write. From that, see Sy equal to Uy t plus half A T square. Yes na? See we can write here Sy means along y axis D by 2. Distance is, displacement is here D by 2. Vy, this value 0. Why? Because V value is 0. So means initial velocity along y axis 0. Half A means QE by M Ay along y, acceleration along y axis. T means we don't know, we can write T square. See here 2 cancel. See what we can write, D equal to A, sorry, QE by M T square. This will be changed. This is M D by QE that equal to T square. Means T equal to what we can write? Root of MD by QE. So means what is the time taken to just cross the plates means MD by QE. MD by QE. But here what we find out, what is the initial velocity we want to find out. For that we can write, see for that, see here what we can write. So Sx equal to L. Yes na? So we can write here Sx equal to ut plus half at square. So mean this value 0. Why? Because acceleration along x-axis 0. Here u means uy. We can write Sx means here L equal to uy. Uy means v naught into t. So I write here. So L equal to v naught into t. We want here what is the initial velocity. That's why we can write v naught equal to L by t. T means what here? Root of md by qe. So means v naught equal to L by root of md by qe. Root of md by qe. So means it will changes to numerator now, v naught equal to L into qe by md. What is the initial velocity? At what minimum initial velocity the charged particle just crosses the plate now? L into root of QE by MD. Again listen once this problem. See, find the minimum value for V naught. At what minimum value of charged particle, minimum value of initial velocity, it just crosses the plates. For that it is the uniform electric field. Electric field is this one. So positive to negative is there. This is the charged particle initial velocity v naught. We don't know, that we want to find out. For that this distance is d by 2. This total distance between the plates is d. This is the deflection along y axis. This is the deflection along x axis. X axis is L length, y axis d by 2. We can use force equal to QE, ma equal to QE, ay equal to QE by m. Means acceleration along y axis only is there, that is ay equal to QE by m. So along x axis, y axis, we can write what is initial velocity, what is the acceleration, everything. Initial velocity v naught, acceleration 0, t equal to t, sx equal to L along x axis. Y axis vy equal to 0, uy equal to 0, acceleration along y axis qe by m, along y axis deflection is y. So that y value is what here? D by 2. Already given in the problem, it will d by 2. So just we can substitute s equal to ut plus half at square. Along y now we can write y. So along y now d by 2. Uy is 0, already you know here. See, half ay means QE by m. I write here t square, 2 cancel. So m is change here md QE. Md by QE equal to t square. T equal to what? Md by QE. Means what is the time taken to cross the plates means t equal to root of md by QE. How much time this is here? T equal to root of md by QE. Now we find out what is the initial velocity. At what initial velocity crosses the plates? For that Sx equal to ut plus half at square. A value 0. That's why Sx equal to ux into t. Here Sx it means L length equal to ux na v naught, t value t. L equal to v naught into t. So means v naught we want, so change this one, L by t. V naught equal to L by t. V naught equal to L by t value is what? Root of md by qe. I write here root of md by qe. It will change to numerator means qe by md. What is the initial velocity of charged particle just crosses the plates na? V naught equal to L into root of QE by MD. L means here what is the length of the plates? Q means charged particle. E means electric field. M means mass of the charged particle. D means distance between the plates. Distance between the plates. This formula we can use and find the initial velocity of the charged particle. Then it will just crosses the plates. For just crossing the plates, what is the initial velocity of the charged particle? Now V naught equal to L into QE by MD. Root of QE by MD. Root of QE by MD. Next one. See next one, fourth one. See, is a electric field, uniform electric field. This is the uniform electric field. See, here Bob is suspended. here bob is suspended. So it is the uniform electric field. Electric field is positive to negative is there. See here, at what minimum velocity we pull, we push, it will be complete the circular path. Find the minimum velocity at which we want, what we find out now. Find the minimum velocity. Minimum velocity of u, the bob complete circular motion. That minimum velocity we want to find out. See, it will move with moving with some minimum velocity u. That minimum velocity we find out. For that, it is in the uniform electric field. Due to this, it will be applying some velocity, minimum velocity, that it will complete circular motion. Yes, na? See here, for that, see any particle, see this bob is in, here we apply minimum velocity, then it will complete circular motion. For that, at what minimum velocity the bob will complete circular motion, that minimum velocity we call it as the critical velocity. That critical velocity formula is root of 5gr. 5gr. Here one more important is, it is gravity free space. First we can discuss gravity free space. No gravity, gravity free space, free space. Then only we find out first what is this one. See, for this, in this case now, what is the velocity now? Root gr. For completing circular motion, what is the initial velocity now? That velocity we call it as critical velocity. That critical velocity is root of 5gr. It will be learned in circular motion in 11th standard, but we can use here. So vc means critical velocity. At what minimum velocity the bob will be moves, then it will complete the circular motion. That minimum velocity, minimum initial velocity, we call it as critical velocity. That critical velocity is root of 5gr. Here is force is acting on this one, F equal to QE. F means here MA, A equal to QE. So A equal to what here? QE by M. So means in this bob only one force is acting, that is this one. So that case F equal to QE. From that, what is the acceleration? See, A equal to QE by M. A equal to QE by M. This is the G effect in gravity free space. So that's why what is the critical velocity we can write here, root of 5. G value means this only, acceleration due to gravity, acceleration only. So acceleration along y means here this is QE by M. So QE by M into r. R means here radius, this one from here to here. What is the radius of circle? So means r. So this is the critical velocity, means minimum initial velocity for completing the circular path in uniform electric field in gravity free space. If gravity is there, if gravity is there, what is the critical velocity? That also we find out. For that, see now, if gravity is there in this bob, it is in uniform electric field. Now here two forces acting, one is QE due to electric field, due to electric field, what is the force acting on that bob now? QE. And one more it is acting, that is weight, acceleration due to gravity. So means weight is acting down, two forces acting, that case. So total force equal to what? QE plus mg. So we want here ma na, acceleration we want QE plus mg, acceleration equal to what? So QE by m plus mg by m. So means mm cancel. What is the effective acceleration? Means this we call it as effective acceleration, that is QE by m plus g. This is the effective acceleration along y axis. See on the bob when it is in the uniform electric field. See when it is in uniform electric field, what is the minimum initial velocity na? Gravity free space means root of 5 QE by m r. In gravity now, in gravity na, what is the acceleration means here? Before that, in this one two forces acting, one is weight and another one is electric force. So both. So due to that, what is the acceleration? QE by m plus mg by m, mm cancel. Means effective acceleration is QE by m plus g. But what is the initial velocity? Initial Minimum velocity for circular motion in uniform electric field. So Vc equal to root 5 gr. We can write here critical, that we call it as critical velocity, root of 5. G means G effective here. G effective is what here? It is G effective. Means what here? So QE by M plus G into R. This is the minimum initial velocity to supply to the bob when it is complete the complete the circular motion. Understood now? This is the minimum initial velocity of the bob to complete circular motion in gravity. Is gravity space is we see equal to root of 5 QE by M plus G into R. In gravity free space na root of 5 QE by M into R. This is the solution. Yes na? See next one. When the bob is in uniform electric field, what is the time period of the that bob? That we find out. See, for example, fifth one is the plus charge. Here, negative charge. Electric field is from positive to negative. Here, bob is there. Yes, now bob here. This one. What is the time period of that bob? See, when it is in uniform electric field. So, time period, find time period. Find time period of the bob. Yes, now see for that what is the time period? 2 pi into root of L by G. L by G. See here G means here G effective. For that we can write here two forces acting. One is QE electric force, another one is weight mg. From that G effective means acceleration we can write. So force now net force we can write F net equal to what? QE plus mg. F net means MA equal to QE plus MG, A equal to QE plus MG by M. So that means A along Y, acceleration along Y axis, QE by M plus MG by M means MM cancel. What is the A value? Acceleration or effective acceleration is equal to what? QE by M plus G. This is the effective acceleration. Just we can substitute here. What is the time period? T equal to 2 pi into root of L by G. Effective means QE by M plus G. This is the time period of bob when it is placed in the uniform electric field. Uniform electric field. Yes, na? See next. Recent JEE question, what that na? See once, uniform electric field is there. See, this is the uniform electric field is negative. See, electric field is from positive to negative. This electric field is 9.1 into Newton per Coulomb. 9.1 Newton per Coulomb. Here particle, charged particle is moving with initial velocity, that is 10 power 6 meter per second. What is the initial velocity of the particle? Na? 10 power 6 meter per second. See, what is the here what we find out now here? See, once I read the question first. In a given figure shows an electron entering the space between the plates of parallel plate capacitor with an initial velocity is 10 power 6 meter per second. If the length of the plates is, this length is 10 centimeter. What is the length of the plates na? 10 centimeter, and electric field in the region is 9.1 Newton per Coulomb. Then the value of Vy, find the value of Vy means final velocity along y axis when the electron comes out of the plate. When electron comes out of the plate at what velocity it will be comes out of the electric field. See here, this is the electron they mentioned electron, it is moving in the uniform electric field. In this case, what is the electric field? Na? E equal to 9.1 Newton per Coulomb, and initial velocity is V naught equal to 10 power 6 meter per second, and length of the plates is 10 centimeter. This case, what is the final velocity of the electron when it comes out? That case, what is the final velocity of electron? That we want to find out. For that, see here, it is the actually path, it is deflecting electron this direction. At what velocity? Here it is along x axis Vx, along y axis Vy. This case, what is the final velocity at which it will be comes out? That we want to find out. For that, so we know already, so Vy final velocity equal to what? Formula na? See, Q E by 2m x square by V naught, x square by V naught square, x square by V naught square. So means what is the deflection? Now we write QE by 2m, QE x square by 2m V naught square. Before we discuss this one, yes na? So y, what is the total deflection along y axis? But here what we find out, what is the final velocity at which it just comes out of the plates? For that, what we find out now here first, acceleration. So acceleration along y axis. What is the formula? QE by m. QE by m. See, this is the acceleration of the charged particle along y axis. Here final velocity na we write Vy equal to Uy plus At. V equal to U plus At na. Uy is what? 0. So Vy equal to A. A means this one. QE by m into T means x by V naught na. We find out. See, for example, already we find out along x axis what na ux equal to V naught, Sx equal to x, t equal to t, acceleration along x axis is 0. From that, s equal to ut plus half at square. We can use s means x, x equal to u v naught into t plus half, a value is 0 along x axis. So that was this 0. So x equal to what? V naught into t. So means t equal to what? X by v naught. So when the charged particle is in the uniform electric field, that case, what is the time taken to cross the plates na? T equal to x by v naught. So that we can use here, x by v naught. Yes na? So means what is the v value? V final velocity along final velocity of the charged particle when it just crosses the plates, comes out of the plates na? Vy equal to QE by m into x by v naught. What is the q value? Q is charged particle na. So what is q value? Means here charge on electron only 1.6 into 10 power minus 19 coulomb. Next na E value electric field. Electric field they give what? 9.1 into 9.1 Newton per coulomb. Next na M value, mass of the electron is what? Mass of electron is 9.1 into 10 power minus 31 kilograms, minus 31 kilograms. So x value na here length of the x value length only, length of the plates what na 10 centimeter, x equal to 10 centimeter. Yes na. See v naught value, initial velocity what? 10 power 6, v naught equal to 10 power 6 meter per second. By using these values we can find the final velocity of the charged particle electron just comes out of the plate. So what is the formula? Vy equal to QE by m x by v naught. How it will get na? See, actually acceleration QE by m along x axis na ux equal to v naught, vxx equal to x, t equal to t, acceleration along x axis is 0 by using s equal to ut plus half at square, x equal to what? V naught t plus half, acceleration along x axis is 0, it is total value 0, x equal to v naught t, t equal to what? X by v naught. Along y axis, this is the deflection QE by 2m v naught square x square. So along x axis we can use and find the x value, t value, that is x by v naught. So means deflection, or what is the final velocity? Now final velocity what? Vy equal to uy plus at, uy 0, vy equal to a, this value, t value, this we can substitute. Then what is the vy value here? QE, q means 1.6, into 10 power minus 19 coulombs into E value 9.1, 9.1. So x value 10 centimeter means 10 into 10 power minus 2 by m value 9.1 into 10 power minus 31 into V naught value 10 power 6 meter per second. See, 19 plus 2 21. So 21 here 10, 31 is there. So 10 we get minus 10. Here 4 6 4 we get minus 4. See 9.1 9.1 cancel. What now here see 1.6 into 10 denominator 10 power minus 4 is there. Numerator means 10 power plus 4, 10 power plus 4. So means Vy equal to final velocity of the charged particle 1.6 into here 1 is there 10 power 4 plus 1 10 power 5, so meter per second. What is the final velocity of the charged particle when just crosses the plates na? 1.6 into 10 power 5 meter per second. So this is the final velocity of the charged particle. For this, what first we can do now? We find out t value, y value. Uh, this is deflection along y, not Vy. Sorry, y deflection along y, deflection along y axis. This one. See, what is the final velocity of the charged particle just crosses the plates? In that case, Vy equal to u plus at. We can use uy 0. So Vy equal to at. A means this one, t value this one. From these equations of motion, we find out t value. So that t value we can write here. This is the final velocity of the charged particle when just crosses the plates. That case Vy equal to what? Qe by m x by V naught. So Vy equal to Qe by m. Q means charged particle, charge on the particle, E electric field, m mass of the charged particle, x means distance, means length of the plates, V naught means initial velocity of the charged particle. We can substitute, we get this value. What is the value now? 1.6 into 10 power 5 meter per second. At what velocity the electron comes out of the plates na? 10 power 1.6 into 10 power 5 meter per second along y axis. This is the velocity of the charged particle. So thank you.